In this situation, we're taking the antiderivative here, and they tell us we want to use u as 9 minus x squared. So that would be that du would be negative 2x dx, correct? Now, I've got an x dx in the problem. So to get x dx by itself, I divide out by negative 2. So negative 1/2 du would equal to x dx. So at this point right here, I've now got the integral of negative 1/2 of u to the 1/2 du. Is everybody okay with that? All right. Now, from here, they tell us that these are our lower limits of integration when our domain is x. My new domain is u, so I need to write these x values here in terms of u. So this is going to be 9 minus 0 squared, and this is going to be 9 minus 3 squared. All right, is there a question about that? Those are my new limits of integration. Now, again, this doesn't have to be done, but I would rather my lower limit of integration be less than my upper limit of integration. So I'll flip these around, and I'll be going from 0 to 9 now. So when I flip my limits of integration around, this becomes positive 1/2. Is there a question about that? Yes?
How are you able to change the, like, 9 minus 3 squared, but why?
All right, your question is, okay. Question is about why is this 9 minus 3 squared?
Yeah.
Because it's 9 minus, my u value is 9 minus whatever x is. In this case, it was 3. So it's 9 minus x squared, which would be 9 minus 9, which would be 0. Did I answer your question?
Okay.
Okay. Any other questions here? All right. And likewise with the 0 there. Okay. So now it becomes 1/2 of, okay, what is the antiderivative of u to the 1/2? All right. So it's 1/2 of 2/3 of, all right, this is the square root of 9, which is,
3.
and 3 cubed is
27.
27. Okay. And then plugging in 0, it's just 0 here. And from here, this would be 1/3 of 27, which would be 9.
I like that. I think it's balling.
Groovy. Any other question? What's happening here?
After you found the antiderivative for u to the 1/2, when it says 9 and 0,
Mm-hmm.
does it matter? Like, for
This is when I plug in 9?
no, like it. Never mind.
No, ask the question.
No, cause like, what are those numbers called? They're like, but not bounds.
Limits of integration.
Yeah, like the number, 9 and 0, like they flipped. Is that why negative 1/2 went to positive 1/2?
Yeah.
Yes.
Okay.
Yes.
negative.
Say that again?
Because you're just taking negative out, because it would have been 0 minus
Yes,
9. Instead we make it 9 minus 0.
yes.
Where you have a positive there.
Now, I said I like doing this because I would rather my lower limit of integration be less than my upper limit of integration. But I guess more than that, I like this value out front being positive instead of negative. So if this had been negative and this had been 0 and 9, I probably would have still flipped it. Yes?
Pretty stupid, but why is it 1/3 times 27?
Well, this becomes 0, right?
So,
So 1/2 of 2/3, those cancel out. So it's 1/3, 27. Yeah.
does it matter that the answer is the upper limit of inversion? Is that
No, I mean that doesn't typically happen. It did in this case. That's fine.
What happens if you have an answer that's outside? You did something wrong.
That's outside of what?
Like if like our answer was 10. by
Okay.
chance, it would
Now,
be-
all right. So great question. That would be fine. What this is going to end up doing. Remember what we talked about earlier. We talked about finding area under curves, right?
Yeah.
Summations and all that stuff.
Oh, this isn't like exact.
Well, this is going to be your exact answer
Oh.
for area. So if I want to know the area under the curve of this from here to here, the answer would be 9. So the area can definitely be greater than. It just depends
It
on.
just depends on the like actual graph.
Yes.
Because like if you have, it could be a triangle graph and then, okay, yeah, I get it.
So this is going to end up being an area, essentially. Are we okay here?